Well, good afternoon to our East Coasters, and good morning, good mid-morning to those folks on the West Coast and central part of the United States. We really do appreciate your time this morning or this afternoon in learning about the benefits for reality capture. IMAGINiT Technologies is a full-service technology firm, and we are not only the largest Autodesk reseller, but we also are very good with custom solutions. And today, since we're focusing on the benefits of reality capture in manufacturing, we are so fortunate to have on the line Rusty Belcher, our application expert here at IMAGINiT. He's going to be primarily presenting all of the benefits, bells, whistles, features, and adoption on reality capture. So with that being said, I'm going to turn it over to Rusty so we can maximize our time together today.
Well, thank you, Beck. I appreciate that. Hello, my name is Rusty Belcher, and again, I want to thank everyone for being on the call today and taking some time out with us. I'm planning to go roughly 50, 55 minutes or so. Hopefully, we'll have some time at the end for questions. So I want to jump right in, talking about the benefits of reality capture in manufacturing. Just a little bit of an agenda. We're going to take a look at the various methods of documenting reality. There are quite a few. We're also going to look at how the factory designers have kind of been leading the way in the charge here using reality capture, and in a lot of ways bringing it to the forefront in manufacturing. When we talk about reality capture, we're going to talk about combining reality with your digital data. And the opportunities for process improvement that are there, that are waiting for you by adopting some reality capture workflows. We're going to talk about working with reality capture data instead of traditional solid or surface models. I think you'll be impressed by that. And finally, we'll finish up by talking about developing customized designs based on personal human dimensions. And we'll talk a little bit about photogrammetry in that particular section as well. Let me share with you, I guess, my first reality capture project. This is kind of an old folks. I have a lot of gray hair on my chin now, and I can tell some old stories. And I thought we'd start off by talking about where reality capture used to be. I remember I used to work at a shipyard. And very proud to work at this particular shipyard, largest on the East Coast. I worked in a place called the mold loft, and we cut steel, all the steel for the shell of the ship. We cut that steel, and we built the documentation for cutting that steel. So one day a cruise ship comes into port, or comes into the dry dock, and a guy shows up in our office with this big letter E. It's 3 foot tall, 1/4 inch thick steel. And he says, listen, we're changing the name of the ship. We have a bunch of these steel letters, but we're missing a few. Would you guys cut us out some new letters? Sure, no problem. And he says, this letter is the correct font, but it's the wrong size. So it's a 3 foot letter E. He needs a 4 foot letter E. And then he says something that I'll never forget. He goes, we also need a letter Z. But we don't have one of those, so you're going to have to come up with the way to create the letter Z from the letter E. Now, this is 20 plus years ago. AutoCAD is really, we're talking probably Windows 95. Maybe we've gone into a little bit of 97 and things like that. So we looked at each other. This happens to be the day where our boss is off on vacation, and we have no idea what to do. I had seen one of the guys in the office joining us. He had a camera pass, and he had what was the first digital camera I've ever seen. He used to have the floppy disk, the 3.5 floppy disk that went in the back of it. And I went over and asked if he would come over and take a picture of this letter E. We hung it up on the wall. And we hung up the rulers in beside us so we could have scale. And he took a picture, and we put that picture into AutoCAD. We traced it, and then blew it up to the correct size. So that gave us the 4 foot letter E. And then we used the bits and pieces of the font to create the Z. But that was the first time we had adopted any kind of reality capture process. It was with a simple digital camera to get a picture into AutoCAD. we took that process and we started to generate 3D forms from molds. We would go out and take shell forms. We would take a boat would come in with a big dent in the side of it, and we would go out to the good side of the boat and take a 2D form and make a 2D batten or wooden form, take it back up to the office, take a picture of it, and 3 or 4 of those forms in a row in AutoCAD 3D would give us a surface of the ship that we needed to fix. So we take the good side of the ship, mirror it to get to the bad side, and we used that digital camera in our reality capture projects early on, and I was really proud of that. I didn't know it at the time, but that was kind of like the pioneer days of reality capture. Well, nowadays we have come a long, long way. A long way from the, originally going out and taking hand measurements. The digital camera is great, but we now have really high-end forensic-level scanners that do a tremendous job in the field. Many of you are using ARM-based digital measuring tools so that you can generate, detail scanning by clicking a number of points on a machine, very high accuracy scanners. And we've kind of gone full circle. We're now bringing the digital camera back into the process for things like photogrammetry. If you take enough pictures of an object, there are now programs that will stitch those pictures into a 3D form for you. So there's all types of methods of going out and capturing reality now. And the process that you choose really does become a factor of the company that you work for. How much can you afford for it? How much time do you have? How much skill or expertise do you want to designate towards this particular process? Well, I have a question, I guess, for you. This is a question I ask a lot these days. Why has manufacturing been so slow in adopting reality capture? I'll give you my take on that, and I think that primarily, right off the bat, when I talk about manufacturers, the first question they ask me about laser scanning is how accurate is it? And then we start talking about time of flight and how long the laser is, going to and from the object and how far the object is from the scanner, and we start talking about plus or minus a full millimeter at so often or such a distance away from the scanner, and that just turns some manufacturers off right there. If it's not going to be 100% accurate, I don't want anything to do with it. Well, nowadays, accuracy is amazing with laser scanners. It's never going to be 100% perfect. It never will be, but the accuracy is incredibly detailed now at objects that are roughly close to the scanner. The other side of it is time, skill, difficulty. Scanning, I think, has been perceived for a long time as a dedicated science. You need a surveyor to go out and read the instrument and to program it in correctly. And it has taken time in the past, putting people in the field for multiple days to collect data. It's not the case anymore. You're going to see a scanner here in a minute that can take a scan in about 3 minutes and can take multiple scans in a couple of hours. And it's extremely easy to use, single button interface now for laser scanning. The other side I think we'll talk about with manufacturing is the reality versus CAD argument. We spend all of our day inside of CAD looking at perfectly straight lines that might represent walls or machining planes. And then we realize that in reality, those parts aren't flat. They're close to being flat, but they're not perfectly flat. Those walls are plumb, but they're not perfectly plumb. Reality is different. When you harvest reality, it doesn't perfectly line up with your CAD data, so what do? And then finally, cost. I think, manufacturers, not all the time, but predominantly, they produce small objects, and they have to produce a lot of them in order to make a profit. They're not like architects doing major buildings and big, huge projects that cost just thousands and thousands of dollars. A laser scanner, conventionally, laser scanning has been $100,000 to $200,000 to buy in to begin with. And that puts a lot of manufacturers off. We just don't have room in our budgets for an expenditure like that. Well, nowadays, it's amazing what laser scanning can be. I remember a few months ago, it's been months really, honestly, when I read about the BLK360. This is a product from Leica. This is a brand new laser scanner from Leica that targeted that $20,000 range. So you want laser scanning, I call it entry-level scanning, affordable by just about everyone. This is, I think, the scanner a lot of manufacturers have been waiting on. And we talk about in design, we talk about disrupting the market. We talk about getting to market first, making a disruption, putting a product in place at a price point that no one else can touch. And Leica, this is a fantastic example of that. They brought this to market. It's really not like any other scanner we have ever seen before. And people are going crazy over this thing. The quality of the scan is fantastic. Good enough, I think, for a lot of manufacturers who have ignored laser scanning up until this point. Now all these manufacturers are really starting to perk up and take a look at this because it's affordable. This is the idea that reality capture for everyone at this particular juncture with this particular product. I use the BLK. I'm on the manufacturing team at IMAGINiT, so I primarily am an Inventor guy, an AutoCAD guy, Navisworks. I do a lot of work with the factory design utilities, and I've been so impressed. I moonlight in IMAGINiT over on the reality capture team. I love being a part of that team. But up until this point in history, they would never let a mechanical guy like me take the $100,000, $200,000 laser scanner home and play with it because it's such an expensive piece of equipment. Believe it or not, they let me take this particular scanner home. And I had a wonderful time going around the neighborhood scanning a few objects with this scanner. It was so easy to use. The idea is it's a small, lightweight, simple to use imaging laser scanner made to deploy scanning technology to everywhere to everyone. There's no limit anymore. There's really no excuse not to look at reality capture and bringing those workflows onto your team. The size of this scanner, roughly about the size of a cell phone, about 6 inches tall, 4 inches in diameter. Very lightweight. You can easily move this thing around. I'll talk about the specs here, and then I'll talk about putting it in the overhead compartment on an airplane. But the specs, you might want to take a screenshot if you have your computers ready to go here. Most of the time when I'm asked about cameras, I'm asked about the range of a scanner. So we take a look at the range and from 60 centimeters out to 60 meters, 2 foot to 200 feet. That's the range this scanner would work in. And then the accuracy, I always get questions on that, so I put that up on the screen. 1/4 of an inch at 33 feet, 1/3 of an inch at 66 feet. And of course, the closer you are to the scanner, the better your resolution / accuracy would be. The scanner on the right side, I won't go into all the specs, but there are 2 sides of it. The side that has the business end has 3 HD cameras, one that points up, one that points at about a 45-degree angle, and one that points out. There are flashes that it can deploy a flash for its own cameras very easily. It has an LED ring at the bottom that communicates to you, that tells you, hey, if I'm ready to scan it, it glows green. If it has a problem, it might ask you a question with a yellow marker, or if it has a problem, it can glow red if it needs some help from you. But it basically sits on the top of a tripod or on the ground, and it spins around, takes a full 360-degree spherical image, and shoots the point clouds about 360,000 points per second. Colors those points based on the spherical photo, and delivers you, I think, a very high-end point cloud scan in very little time. I'll mention this now, and it's probably on another slide, but at a medium density scan, this thing will complete a scan in right at 3 minutes. which is very nice for a scanner. I mentioned the price point is around $20,000. That is for the basic scanner. If you want to spend a couple of $1,000s more, you can get the Mission Expansion Kit, which is the carry case, the tripod, the cover, the battery, extra batteries, always great to go in the field with extra batteries. So there are some additions, but this particular kit represents what we think goes in the field most of the time, every day with the BLK 360 project. This kit is small enough and light enough to carry through airport security. It easily goes in the overhead bin on an airplane. I was at a customer site a couple of weeks ago where they have a full high-end, very expensive laser scanner. It's a construction firm. But they just got a few of these BLK 360s. Now, no one wants to touch the large scanner because it's so bulky and it takes so much time to get the thing into the field. They want the quick and easy to use BLK 360 because it's so lightweight. They can throw it in the trunk of the rental car, go to the plane, take the scans, come back to the office, be back in the office the same day. So it really is breaking a lot of ground in the scanning industry. Now listen, I absolutely need you to pay attention to this. These things are not equal. There's quality in the scan. You're going to see a much higher quality scan from the P series, the high-end scanners. The fidelity is going to be much greater. There'll be so many more options built on the high-end scanner. The scans are great. They're reliable. They're roughly the same resolution. But there are a few issues. Some of the issues, I'll be honest, the BLK has a hard time scanning very, very dark colors like black. It needs a good return from the color of the object you're scanning. So we don't get a good return on very, very dark objects like black objects. It's just the function of the laser and the power they put into the scanner. So you want to take some care in investigating your process and choosing the correct scanner. But given the issues with the Leica, the limited issues, it's still a great first choice to get into reality capture. I think this is a great first scanner for any company to adopt and to get used to the reality capture workflows that are available in in all design products, but specifically the Autodesk products. The workflow with the BLK out of the box, you typically get an iPad. The iPad's not included in the price. You need an iPad Pro. And by the way, you don't need it, but I'll show you another workflow in a moment where you don't need the iPad. But basically, the iPad Pro, the 12-inch or the 10-inch, has to be the Pro because that's the only iPad powerful enough to run the recap software. But the iPad hooks up via Wi-Fi to the scanner so that you can start the scan. So you don't have to be right in way of the scanner to start it. There's only a single button to press if you want to press it manually. But the iPad starts the scan. It also registers the scans. As you start creating multiple scans, it automatically stitches them together for you. You can manually do registration, picking 3 points and aligning the scans yourself. But you don't have to. The iPad will do it for you. Manual measurements, you can take quick measurements on site through the iPad. You can actually measure the cloud while it's on the iPad. And also we use it to transfer the data from the device to your desktop recap application. So you'll take your iPad back to the office, hook that up to your desktop, and translate the data from the iPad to your computer. I mentioned that I got a chance to take this thing home. I'll be honest, it was, I believe, number 59 off of the product line, the 59th scanner that came off of the line, and we got a chance to use that. Jeff Bowers is one of our reality capture experts. He took me out on site, and I'll share with you real quick. I don't mind. I've got my recap application open here. this is the first scan Jeff did with me. I'm still a shipbuilder at heart. So I've got Autodesk Recap here, and we went over to Portsmouth, Virginia, where there is a park right up beside the river, and they have what's called a light ship. This is a floating lighthouse. It used to be a floating lighthouse. It's a ship that was meant to put out into the bay and act as a lighthouse. It's kind of a famous light ship. It's actually a pretty nice one. But it's in a park right now, and it was a perfect scan for us to go out and practice. And you can see if I zoom out a little bit here, we turn on the mirror balls, you can actually see the river off in the background. If I jump in here, you can see, basically what we had to look at that particular day. I'm joking around where there's Jeff and me. This is how difficult scanning with the BOK is. The scanner does all the work. We're just sitting there minding our own business. There's the iPad, and there is the ship that we're scanning. Things that are really, really, really close to the iPad will start to duplicate on the image. That's just the function of things being too close to the device. But the further you get away, the more accurate the scan's going to be, again, up until about, 60 feet away. So this is plenty of resolution for us to go out and grab the ship. And we can come in and this is the very first time I ever got a chance to use it. And I was amazed at some of just the cool work we could do with this. I'm in Recap, and I'm just going to go up and grab a point snap. Let me grab a dimension. And measure from one point to one pipe to another pipe. So we can actually take measurements like that using the point snap tool. Really nice benefit, or a nice little cool feature here. But being able to measure reality, being able to measure the distance between buildings, things like that, or the parts, the mechanical parts that you're looking to record for whatever purpose. So this is the first one Jeff taught me about. And then he let me, believe it or not, he let me go home, and I scanned some stuff at home. I live pretty close to the bay, and there is a restaurant in my neighborhood. And I went up to the restaurant. The restaurant's closed for the season, and the owner is working on a shrimp boat out behind the restaurant, so right in the parking lot of the restaurant. And I got a chance to set up and scan the shrimp boat. This is the very first scan I ever did on my own, right after training. And the scan, it turned out really good. I was really surprised at the fidelity of the scan, how clean it was. And I'm going to jump over into Inventor for a minute, and the overall goal is to get this into your CAD software. It turned out, in Inventor, it turned out really well. The idea that you can capture reality and get it into your CAD system, what workflows does that open up for you? Well, in this particular case, I'm a shipbuilder at heart. I still focus on that a lot. The complex shape, or trying to develop the complex shape of the hull of the ship, I would need a bunch of splines in order to do that. Well, let's see. In Inventor, I could come into the Manage tab. Let me just go to the left side of the ship here. I should say Boat. I'll do just a simple box crop. Now, I'm doing this as fast as I can because we only have an hour together. But I can take just a swath of points right through our design, click my check mark, and then I can look at that from the front, and there is the line that I need to trace in order to generate that hull. If I put a sketch plane there and crop out the boat, I now know what that hull looks like at that specific point. Now, I'm doing this as fast as I can. Obviously, you want to take a bit more care, but that's how you can capture reality and put it in your computer for your use. Remember where I started this, when I was a kid back at Newport News Shipbuilding, all the work we went to capture this line for a shell of a ship and to put it into a CAD system, and here I just did it in, well, counting the scan time, took about an hour to scan the ship, come back up, takes me just minutes to get this into Inventor. This is no trouble at all. It's amazing how far reality capture's come just in my experience or my career path, the time I've been using Inventor and AutoCAD. It's amazing what we can do with reality capture now. I mentioned before that you do not need the iPad in order to generate laser scans with that BLK 360. If you just want to take the scanner, set it up, and press the button, it'll generate a Leica quality or a Leica-centric point cloud. It's a Leica proprietary point cloud. If you're invested in the Leica tools like Cyclone, Jetstream, or CloudWorks, those scans go directly into those applications and they're fully supported. There's even other tools. There's registration tools that Leica has that can take all of those scans and help you register them and get them together oriented correctly so that you can use in your downstream applications. If you're on the call and you're really not familiar with the Autodesk product line, in order to utilize the point clouds in Inventor or AutoCAD, you have to put them through Recap first. But again, if you're invested into the Leica tools, at the end of it, you can generate a cloud that was readable into Recap and then into Inventor. I thought I'd talk a little bit about a few of the customers we've worked with. I'm not going to mention names, but I will mention some of the processes and some of the things I've gotten to scan just in the past half year with the Leica BLK 360. We offer what's called a Smart Start program. People who have already bought the scanner, they'll bring us in for usually 2 days. And during that 2 days, they'll take us out into their facility. They'll say, hey, we want to scan this. And we'll go through that first scan, just what Jeff did with me. He went through the first scan with me. We'll go through the first scan with you. That scan could be multiple scans. It could be multiple pieces of equipment or places in your facility. We then usually we scan in the morning and the afternoon. We go back up and we load the data into your CAD software. Usually, if I'm on site, we're talking about using the CAD data or the point cloud data in Inventor. Inventor or AutoCAD, but for me, most of the time I work with Inventor customers. And then we talk about, for whatever reason, whatever workflow they have, what are the possibilities of using these point clouds inside of a tool like Inventor. We worked with a customer that creates jet canopies for fighter aircraft. We did not scan the canopy. The canopy is quite reflective. I don't think it would scan very well with the BLK. The high-end laser scanner would scan it just fine. It's a big difference between the two. But we scan the jig, the mechanical jig that holds the scanner, or I'm sorry, that holds the canopy in place. We scan the tool set for that and the jig itself, and it worked perfectly. That thing rolls around the facility. They wanted to scan what they call an asset so that as they move it from one part of the facility to the next part, they could actually assure that it would make it through the pathways and it would dock where it needed to dock for whatever process goes on that particular canopy. We also do what's called a proof of concept with the scanner. This is for customers who are interested in the BLK, but they haven't bought one yet. So we have 2 scanners that we have in our company. We'll show up with our scanner and basically do the same thing. Usually these are about 3 days of an engagement. Again, we go throughout your facility or your company. We scan what you want us to scan. We spend 3 days with you getting the data into Inventor or into, again, with me or the manufacturing side. Usually it's the Inventor application. And we talk about what are some of the workflows that are possible with the scanner. This way you get a chance to see it in action for yourself. You can see the fidelity of the scan, how it looks like inside of the Inventor application before you commit to buying one. We also have customers that are heavily into reverse engineering. Now, when it comes to reverse engineering, a lot of our customers have gone into the high-end scanner range for accuracy and fidelity. But several of them are looking at the BLK as a first pass, a very quick and easy first pass for the scan. Once you get the point cloud, converting it to things like mesh or surface data is not available in the Inventor application. Recap doesn't do it. Inventor doesn't do it. Usually you'll need a third-party software if you want to convert a point cloud to a mesh. We've been working with a tool called 3D Reshaper for this. It does a fantastic job. It also does, it also will convert the point cloud to a flat surface. Any flat in the cloud you can produce as a surface model. Very nice. You can trace the cloud with polylines. That's another feature that a lot of our customers want. They want to be able to quickly trace the cloud to usable 2D geometry. So I usually use 3D Reshaper for that. That's my end. You might be on the Leica side where you're using CloudWorks to do basically the same thing. All of that is supported with that BLK 360 and the high-end P-Series scanners. So I work a lot with the factory design utilities. I've been working with them since they first came out, and I look at the factory designers on the manufacturing side as the first people who really adopted point clouds on the manufacturing side as far as the Autodesk tools go. I remember when point clouds first came out for the factory design utilities, we were very, very excited because we could now scan a facility and then we could lay out our factory line in context of reality. Not long after that, I was in a meeting with some people and we talked about, hey, why don't we just scan the equipment as well? And I can have point cloud assets, real world components that I can move from one cloud to the next and see how they fit in different buildings. So the idea of scanning the factory, of course, is a big point as far as laser scanning goes. But scanning equipment and fixtures is something that's coming up more and more with our customer base in manufacturing. Well, this idea kind of leads you down a very unique process or a very unique possible workflow where instead of spending the time modeling a component, you just, especially if you already have the machine, you might just go out and scan it with your scanner. And then you can combine your point cloud with 3D geometry so that it functions as your 3D model. So if you have a machine and a scanner, you have 90% of the work done already to start doing document layout for putting that machine in the correct spot in a factory layout or a shop layout. The idea of using the point cloud as the model is something that's relatively new. If you haven't seen that, I'll give you a demonstration of that coming up. The idea of using point cloud data instead of surface modeling data is something else that's gaining a lot of traction these days. You're looking at what I call a hybrid capture. We've got a scan of a NASCAR car, and it's sitting on top of a surface, which is the trace of the point cloud itself. So the point cloud, when you go to do your drawings, the point cloud doesn't show up in the drawing, but the trace of it will. And you might say, oh, well, I got to trace a point cloud. Oh, that's horrible. That'll take days. No, it won't. You'd be amazed how easy it is to trace an object if you have the 3D object up on your screen. You can put your point cloud into orthographic mode and trace away. It's very easy to do. So I'm going to jump into Inventor and just talk about that workflow for a moment. I'm going to use the factory utilities, but you wouldn't have to rely on these. You might be looking at this, you might be using SolidWorks or Pro-E, and they have workflows that would be similar to this as well. But in the factory utilities, one of the things I have is access to a number of online assets. So I can, if you, by the way, if you have the factory utilities and you want to try this yourself, just do a search on PC. PC for point cloud should return a number of point cloud assets for you. So I'm going to bring in a building. This is just a sample building I had. And you can see real quickly, I don't know, maybe you can see it or not. I've got the point cloud, and I went ahead and I traced the building. I knew what the offsets were for the walls. The scan is on the interior of the building, so I offset the wall thickness. Took about, I would say, 10 to 15 minutes to generate that 2D drawing. Again, it's easy to trace a building. Nothing very difficult about that. Inside of this building, I'm going to add some machinery from another scan. That's what's so nice. I have another scan. I went on site to another building and I scanned some equipment. Now I want to see how this equipment would fit inside of this building. Well, I have the ability to save these pieces of equipment as assets. I can look from the top and drag them around, and basically I'm going to place them by eye, but I could also place them numerically right in position where they need to go. So these are point cloud components, but a couple of things that I did to these components which I think is really nice. Working with point clouds is really nice with the tool. I'm going to open one of these components. This is not a workflow I would really, as far as the factory utilities go, this is not really right, but I want you to see it. I actually went in and modeled components, connectors for conduit. There's a lot of drops that support these machines. The drops have to, from the ceiling down for the electrical work and possibly for airflow, things like that. But how do you draw on a 3D point cloud? Well, in Inventor, we do have tools that help you do that. On the Manage tab, we have tools like the Cloud Plane tool. So if I want to sketch on the side of this panel, I simply put a plane there, and then I can sketch on it. If there's a particular feature that I have to, for whatever reason I want to add to the design, or I'm thinking about adding an extra control panel here, I can absolutely do that. And now I have what I call a hybrid design. I have a design that's half point cloud, half solid. Well, what does that buy me? Why would I want to add some 3D features to a point cloud? Well, remember what I said. I have to add drop data. I have to add conduit to this. So I'm going to ground this just so it doesn't move on me. And I'm going to look up for some pipe. I have a number of pipe assets available to me. This is an elbow that I generated. So if you have the factory utilities, you might not have this one. But this is a regular Inventor part, and I can use the constraint tools. Let me drag this around. Get it up here closer so I can see what I'm doing. There we go. And I can constrain that elbow right to the side of that panel. I'll go ahead and rock it around. Let me grab a piece of pipe here. Again, this is just conduit. Notice that the conduit will automatically resize to the elbow. And then I can simply select the parameter for, 144 inches for that to go up into the ceiling. So I have a solid model hooking right up to a point cloud model. And I just, I'm using the solid data to connect the two together to make it as versatile a design as possible. Well, let's carry that idea forward just a little bit more. Let me go back to my point cloud assets. Let's see. I've got a lathe, so let me bring in I've got a couple of lathes. We'll put them back here into the shop area. I've got a couple of drill presses. Can place those in here as well. Again, these are all reality capture scans that come from different scans, and I'm able to bring them all together in one environment, and I'm working with reality all the time. I can also, you know, this is the factory utilities. If I want to come in and add a couple of conveyors, I can absolutely do that. If I have 3D models of conveyors, those are welcome. There's nothing, you know, you can still use your conventional modeling designs. So I'll bring in a conveyor model here. I'll bring in a pallet junction there. If you guys have seen Factory Suite, I'm not going to drop a lot of these things in. I just want you to see how easy it is to do. And usually with this, there's a wrapper station. I'm going to wrap our parts in cellophane. This is a model I created a while ago for that. And we'll just place that up right here. So I know I've got room. I can place this right in context of the building. There are ways with the factory utilities that we can run clash detection between the point clouds and the objects. That's a function of Navisworks, but it is a possibility. So I have a design, pretty nice, a design here, and let me go ahead and save it. It's going to save it as a sample file. And let me do something that might be a little unique for you guys. Let me generate a drawing. So I'm going to do the top view of this design. And notice, just in case you're wondering, I have surface bodies turned on. So I'll click OK. And I'm generating a drawing of my building and all the machinery in here at the same time. It's really nice. I don't know if you guys have ever seen somebody, an inventor, drawing views of point clouds. Now, in each case, the point cloud has a sketch that's underneath of it, a little solid, a little surface body that's sitting there that represents the top view. I can only do this in the top view, but it generates the top view of the design for me. Very nice and effective. And of course, if I go into the scan and add some more data, my drawing will update. Let me go back to my PC. And a couple of years ago at Autodesk University, I did a class about scanning my pickup truck. That's my pickup truck. And this is about 3 years old. I did that with photogrammetry. We'll talk about photogrammetry coming up. About a year later, I did my wife's Mini Cooper. And the photogrammetry tools, just in a year, did so much better than they did previously. I was able to generate, by the way, the little NASCAR component. This is a die-cast toy, sits on my desk, and I happen to scale it up. So it's about 8 inches long normally in reality, but I scaled it up full scale. So I did a photogrammetry scan of that. And how about this is the generator. This is one of the very first photogrammetry scans I ever did, putting this in the tail of the pickup truck. So notice I'm working with real-world objects here. I'm not working with 3D models. I'm not working with surface data. But if I, of course, go back to my drawing, all of this information is going to be reflected. And things like, of course, your parts list. If I wanted to bring up the parts list, dock that there. Everything I've added to the design is listed, and of course I can document the building with balloons or the machines, even those pieces of pipe that are kind of difficult to see at the moment. We can document that as well. So this is a fully functional inventor file. Does everything I think you'd expect it to do, but we're looking at reality capture data here. So reality capture is fully integrated into the product design collection tools. Navisworks supports point clouds, AutoCAD supports point clouds, Inventor certainly supports them, and the workflows you have available at this point are just phenomenal. Now, I mentioned photogrammetry, so I'm going to finish up on this particular topic. A couple of years ago, somebody approached us, actually about a year and a half ago. Somebody approached our company and they said, is it possible for me to generate a custom face component, a mask? I need to create those, but I need to create those based on scans of a real person's face. And I want to start off with a video. And at first, when they asked me that question, I was relatively new to the reality capture team at the time. I was a little skeptical. I didn't know if we could do that. But we have a tool called Pix4D that allows you to do photogrammetry from a video, and it works very well, very well. And through that particular tool and a couple of other tools, we were able to develop a custom workflow for this customer that proved the concept that was possible to do that. The original scan you see here, it looks like our poor guy has oatmeal all over himself, but that's the artifacts of the video. We're able to filter those out through a tool called Recap Pro. Oh, I'm sorry, Recap Photo. I need to make sure I call it the correct thing now. They just changed the name of it. Recap Photo allows us to take mesh data. This is a mesh, comes from the scan. It allows us to smooth it out and solve it for what I call a watertight mesh. You can take the watertight mesh into Fusion. Autodesk Fusion is Inventor's manufacturing software of the future, and they have an export utility from the Recap Photo tool that sends this over as what's called a quad mesh. The quad mesh goes into the freeform environment and is turned into a solid component. So when this workflow produces a solid part of a person's face. Now, once you have a solid part of a person's face, you go get the mask or whatever mask you want to deal with, generate the profile, and do an intersection curve between the person's face and the profile of the mask. And then you can generate a custom seal. The custom seal has an attachment to the mask, and it also follows the contour of the person's face. This worked. I thought it worked extremely well. In Inventor, I'll just open up real quickly this particular project. We were able to generate the person's face from a video scan, and you saw the process through Fusion. We were able to generate a solid piece of data. You could also generate surfaces if you want, but I think solids are a little easier to work with in Inventor. And we took the profile of the mask. We did an intersection surface, and we generated a solid body based on those intersection lines. So the proof of concept actually worked out really well, much better than I thought. And yes, I'm jumping from one application to another, but that's what our company does. We look for workflows to solve people's problems. And a lot of times that workflow is going to go from one application that does something really well to another application that does something really well. That's one of the things we do at IMAGINiT. I'll point out here that everything we did in this process was documentable. Everything we did produced drawings that you see on the side of the sheet. Of course, I think this would be more along the lines of a 3D print or some kind of unique manufacturing process like 3D printing to produce this part, but you can produce it in classic terms as well. Again, I'm going to finish up that this workflow, the photogrammetry workflow, allows us to deal with shapes we have never been able to deal with inside of tools like Inventor before. Human form is now easy to copy and get into your application. I'll just open up, again, if I go back to my home area, let me open up a design. Here is a design. This is, I know it looks very anatomically correct, and it looks like something that you would see in a medical magazine. Don't tell anybody I told you this, but that's really a styrofoam wig mannequin head. I scanned that, and it's also a Halloween decoration of a skull and the jaw of the skull. And if I just go to shaded mode and I turn on my shadows, you're looking at Inventor models that have been impossible to create up until this point. But now that we can harvest reality and bring it into Inventor, the number of workflows that open up to us are just incredible. And as manufacturers, you can't afford to ignore the potential of adopting reality capture into your current workflows and practices. It's affordable now. It's easy to access. It's now, I like the word democratized. It's now democratized down. Everyone can do it. So if you haven't investigated what reality capture can bring to your table, now's the time to reconsider that because it's never been as easy or as profitable to introduce that process to your workflow. You guys have seen a lot of the applications of this already. Several of us have ordered our own custom earbuds based on the scan of our own ear. Yes, they cost a little bit more than the normal earbud, but you pay to have that because it's yours, it's unique to you. I mentioned the respiratory masks and the CPAP masks, the idea of being able to generate those. Safety equipment like headbands or visors. Imagine if you're going to go diving in deep sea diving, how much more would you pay for a mask that's custom fit to your face and your profile? Sporting equipment, NASCAR has been scanning their drivers for a long time and generating custom seats that are form, fit, or created and manufactured per driver. I mentioned the canopies earlier. Those canopies for jet aircraft are custom fit to the pilot. The asset collection is also something that people do in video games for virtual reality. I'm not going to chase that down, but this is a very popular topic if you're into the world of VR and being able to go out and scan reality instead of modeling it and then putting that into your video game. So those are all popular workflows that use this particular technique. Well, I've reached the end of my slide deck. I've reached the end of my hour with you. I hope you all saw something that was interesting and something that perked your interest up as far as reality capture and possibly adopting reality capture into your current manufacturing workflows.